Floods are one of nature's oldest and most destructive forces. For centuries, our only real defense was just build higher walls. But what if the key to fighting water wasn't concrete, but data? Today on The Explainer, we're diving into a technological revolution that's giving us the power to see floods coming and, save lives like never before.
I mean, this has always been the impossible challenge, right? How do you fight a flood you can't see coming? For centuries, the answer was pretty simple. You don't. You react. You get caught completely off guard. But now, a revolution in remote sensing and AI is changing absolutely everything. It's like we're getting a brand new set of eyes in the sky. So here's our game plan. We're going to start with the data problem itself, then look at our new eyes in the sky, check out the AI-powered crystal ball, see how we map out the danger zones, and finally, bring it all home to see how we turn all this data into real-world action.
Okay, first up, let's frame the problem correctly, because this isn't just about rising water, it's really about a rising tide of data.
So here's the paradox. It's not that we lack information. We are often literally drowning in it. Weather patterns, river levels, elevation maps, you name it. The real challenge is turning that chaotic flood of data into wisdom. The goal is to get the right insight to the right person at the exact moment it can make a difference.
So how do we get that wisdom? Well, it all starts with just seeing the problem clearly. And that brings us to our eyes in the sky and our first major breakthrough, the ability to actually watch a flood unfold from space.
The core technology here is called remote sensing. Honestly, the best way to think of it is like a planetary health checkup, but from hundreds of miles away. Satellites and aircraft become our doctors, using these incredibly powerful sensors to see what's happening over huge remote areas without ever putting anyone in harm's way.
And this is where it gets really clever. See, not all satellite eyes are the same. You've got optical satellites, which are basically like our own eyes. They need light and clear skies to work. But then you have radar satellites. They're like bats. They send out their own signals and can see right through clouds, through rain, and even in complete darkness. I mean, during a hurricane, that's not just an advantage, it's a superpower.
And here's what that superpower looks like in action. A recent study in Bangladesh, one of the world's most flood-prone nations, used this exact radar data and AI to map floods. The result? 95.6% accuracy. Just stop and think about that. Imagine being able to tell with near-perfect certainty exactly which villages are underwater. It's absolutely incredible.
But, a picture of a flood just isn't enough. To make it truly useful, we use something called GIS. The best way to think of GIS is like Photoshop, but for maps. You have your base layer, the satellite image of the flood. Then you add another layer on top showing all the roads. Then a layer for houses, a layer for hospitals. And suddenly, you're not just looking at a big puddle anymore. You're seeing a disaster in its full context.
Okay, so we can see the present with stunning clarity. But what about the future? To really save lives, we need to know what's coming next. And for that, we need a kind of digital crystal ball. This is where AI really takes center stage.
And believe me, this isn't science fiction. We've got AI models being fed decades of data on rainfall and river flow. They're literally learning the rhythm of the water. The result? They can now predict dangerous river levels, sometimes a full 3 hours in advance. Now, 3 hours might not sound like much, but it's enough time to move your family to higher ground. It's a window of time that saves lives.
The specific type of AI they often use for this is called LSTM, which stands for long short-term memory. And the name really says it all. It has a memory. So unlike older models that just see a snapshot in time, LSTM understands the whole story of the river. It remembers that heavy rain from 2 days ago and knows how that's going to affect the water levels downstream today. It connects the dots over time.
And these models are getting better at a truly astonishing rate. Scientists recently found that by cleaning the data first, basically filtering out all the statistical noise, they could make the AI's predictions dramatically better. How much better? They cut the prediction errors by 2/3. That's a massive leap in how much we can trust these forecasts when it matters most.
So we can see the present, and we can predict the near future. Now let's put those two superpowers together to map out long-term risk and identify the danger zones before a storm even forms.
This is where we go from forecasting to planning. We create what are called flood susceptibility maps. Think of it like teaching an AI to be a veteran city planner. First, you feed it all the data, everything from altitude to soil type. Second, you show it historical photos, pointing out, see this? This is where floods happened before. And finally, the AI takes all that knowledge and generates a brand new map, highlighting all the future danger zones in bright red.
And there's a whole toolbox of different AI models for this job. Researchers are constantly testing them against each other, looking for that perfect blend of accuracy and speed. But the key takeaway here isn't the complex names, it's that these models are now achieving near-perfect scores in predicting high-risk areas. The science is becoming incredibly reliable.
So here's where the rubber really meets the road. This isn't just some academic mapping exercise. These maps are decision-making tools. They literally tell city planners where it's safe to build new housing, where they need to reinforce defenses, and exactly where to locate critical things like hospitals so they stay dry.
So, we've got the data, we've got the predictions, and we've got the maps. Now for the final and most important piece of the puzzle, turning all this digital intelligence into real-world action.
The impact here is just transformative. It means you get a warning on your phone hours earlier than you would have before. It means your city builds its new hospital on safe ground. And when the worst happens, it means rescuers know exactly which neighborhoods need boats and which ones need drinking water, because the data is guiding them in real time.
And the system is getting even smarter. I mean, get this. Researchers are now teaching the AI to read social media. A tweet about a flooded street, a Facebook post about a blocked bridge. This real-time human intelligence from the ground is fed directly back into the models, making them more accurate by the minute.
And at the same time, we're going hyper-local. Cheap, simple sensors can now be placed all over a city, in streams, under bridges, you name it. This creates this fine-grained network that can send an alert to a specific neighborhood saying, hey, the creek behind your house is about to overflow. It's about getting the right warning to the right block at the right second.
When you combine all these elements, the satellites, the AI predictions, the risk maps, the real-time ground sensors, you stop thinking about them as just individual tools. You start to see the emergence of a single, intelligent, multi-layered defense system against flooding.
And that is the heart of this entire revolution. It's so much more than just fancy tech. It represents a fundamental shift in our power dynamic with nature. For the first time, data is allowing us to get ahead of the storm, to move from being reactive victims to proactive managers of risk.
But this brings us to the final, urgent question. Climate change is accelerating. It's making floods more frequent, more powerful. We are in an arms race against nature. Our technology is getting smarter, for sure, but the threat is getting bigger. So can our data-driven defenses evolve fast enough? The answer to that question is going to determine the future for millions of people all around the globe.